Hello everyone. So today we are going to discuss Dumas method, which is used for the percentage composition of nitrogen in an organic compound. If an organic compound is given, so in that organic compound what is the percentage composition of nitrogen is present, that we can determine by Dumas method. So myself Muhammad Ruhul. So let's start this. So this is the device apparatus used, which I have drawn. So in Dumas method, what happened? First we will take organic compound and there we will react the organic compound with copper oxide. So here organic compound, organic substance we have taken. In that organic substance nitrogen is present. So what is the percentage composition of nitrogen, that we have to determine. So we are treating the organic compound with copper oxide in presence of carbon dioxide gas. Then if this reaction occur, then nitrogen gas will be produced. So first definition or reaction for Dumas method. The reaction is the nitrogen containing organic compound is treated with copper oxide in presence of carbon dioxide gas. So in presence of carbon dioxide gas, which gives dinitrogen gas, and this will produce dinitrogen gas. So with the help of this we will estimate the percentage composition of nitrogen. Now take the reaction. So nitrogen containing organic compound. So organic compound will contain carbon, hydrogen and nitrogen. So how much carbon is present, how much hydrogen is there, that we don't know. So we are writing a general formula. Carbon is X time, hydrogen is Y time, nitrogen is Z time. Because we don't know the formula, this unknown compound is given. Now the reaction of this compound is to be held with copper oxide. Okay, the reaction of this compound is to be held with copper oxide. So with copper oxide, what will be the result? Now see, first carbon. So carbon react with oxygen. Carbon react with oxygen to form carbon dioxide gas. Okay. Now balance it. How many carbon? X time. So here carbon will also be X time. Second, hydrogen. How many? Hydrogen also react with oxygen to give water. Hydrogen also react with oxygen to give water. How many hydrogen is there? Y. So here it should be Y. So if you multiply it by Y by 2, then Y by 2 into 2. Y by 2 into 2. 2 cancel. This will be Y times. Next, nitrogen. So nitrogen we will get in the form of dinitrogen gas. Dinitrogen gas. How many nitrogen are there? Z. So here give Z by 2. So Z by 2 into 2. Z by 2 into 2. 2 cancel. That is Z times. So carbon takes oxygen, carbon dioxide. Hydrogen takes oxygen, water. Nitrogen does not react with oxygen, it gives N2. What is left? copper. What is left? Copper. Okay. So balance oxygen. So how many oxygen are there? 2x here. Okay. Plus here oxygen is y by 2. Y by 2 plus no this. So 2x plus y by 2 oxygen. So how many copper will be there? This one only. So 2x plus y by 2, that is copper. So this is the balancing part. Okay. So here we only need the percentage composition of nitrogen, that is this one. We require only nitrogen gas. So what is Dumas method? In Dumas method, it is used for the percentage composition of nitrogen for their calculation. In this method, organic compound is treated with copper oxide in presence of carbon dioxide gas. Then the nitrogen present in the organic compound will convert it into nitrogen gas. Now see, carbon dioxide gas form, that gas will come from this and this. So here what happened? Potassium hydroxide is present. So the carbon dioxide gas is coming, react with potassium hydroxide. Because potassium hydroxide is a base, carbon dioxide is an acid. So this react with this to form salt, that is potassium carbonate. So this treated with this to form potassium carbonate. So CO2 is finished by reacting with this. Water. So water is used to dilute the solution of KOH. Water is used to dilute the solution of potassium hydroxide. So water is also used. And copper. So copper is there. Reduced copper goes. Whatever copper will be produced from the organic compound and CuO will remain here. So in this reaction, carbon dioxide produced, which is acid, react with base to form salt, potassium carbonate, finished. Water, what is produced, that comes and mixed with potassium hydroxide and makes it dilute. This is finished. Nitrogen gas. So nitrogen gas does not react with potassium hydroxide, so it remains above the solution of potassium hydroxide because it does not react with potassium hydroxide. Copper, so reduced copper is present here. Reduced copper. So this is the reaction taking place in the device. Now we have to calculate the percentage of nitrogen, and this part comes in the exam. How can we calculate the percentage of nitrogen? Okay. So see the formula what we will use here. Formula is percentage of nitrogen. So nitrogen we got in the form of N2. Here in the device, nitrometer is the name of the device. There we got N2, nitrogen gas. So what is the percentage of nitrogen? How can we find? This can be found by mass of N2. Percentage, mass percentage, how we find? Whose mass is to determine their mass? By total mass into 100. Suppose we have to determine the percentage of N2, mass percentage of N2. So how can we find what is the mass of N2? Given mass of N2 by total mass. Total mass means mass of organic compound. Mass of organic compound and multiplied by 100. So this will give us the percentage composition of dinitrogen gas. So percentage how we find? Normal formula whose percentage is to be determined their mass divided by total mass into 100. So we have to calculate the mass percentage of N2. So mass of N2 by total mass. Total mass means mass of organic compound into 100. Now the question is that mass of organic compound, this will be supplied in question, into 100, normal is there. So main is how we can find the mass of dinitrogen gas. Okay, how we can find the mass of dinitrogen gas, and that is the main thing. That is the main object we have to find. After finding this, problem is easily solved. Now let us proceed for finding the mass of N2. So for finding the mass of N2, apply ideal gas equation. PV is equal to nRT. PV is equal to nRT. Ideal gas equation. So with the help of ideal gas equation, PV equal to nRT, we can easily find the mass. How? Now, N. What is N? Number of moles. Number of moles can be written as given mass of N2 by molar mass of N2 into RT. Okay. What is R? R is the gas constant, which is written as 0.0821. 0.0821 liter atmosphere per Kelvin per mole. R have the fixed value as it is universal gas constant. Universal gas constant 0.0821 liter atmosphere per Kelvin per mole. What is temperature? Taking temperature in Kelvin, because in the unit of R, temperature is in Kelvin. What is molecular mass of N2? That is, mass of N2 is 14, 2 times 28. So we know the molar mass of N2, 28 gram per mole. Okay. So we know R, we know this temperature in Kelvin, it will be given. Volume. So volume should be in the form of liter. So measure the volume in liter. Pressure. To measure the pressure in the form of atmosphere. Pressure should be in the form of atmosphere. Whose pressure? The pressure of dry gas. Pressure of dry gas. Because it is the gas equation and gas should be dry. So what is the formula for finding the pressure of the dry gas? So pressure of moist gas. Pressure of moist gas minus aqueous tension. Minus aqueous tension. So by this formula, pressure of the dry gas is equal to pressure of the moist gas minus aqueous tension. So this formula is used to find the pressure. So in in question, whatever pressure is given, that is generally of moist gas, and aqueous tension will be given in question. So differentiate. So minus this, you will get the pressure of dry gas, and it should be in the form of atmosphere. Generally pressure is given in millimeter. So we know that 1 atmosphere is 760 mm of Hg. So we will apply this formula. If pressure is given in millimeter, so we can convert it into atmosphere, and this formula is used to finding the given mass of dinitrogen. And once we got the mass of dinitrogen, put the value by mass of organic compound, that will be given into 100. Okay. So percentage of nitrogen in organic compound, how we will find mass percentage? So given mass of this by total mass into 100. How we can find the mass of N2? Formula is PV equal to nRT. What is N? Number of moles given mass by molar mass. Molar mass 28. R is this, temperature Kelvin, volume liter. Pressure should be of dry gas, which is equal to pressure of moist gas minus aqueous tension, and it should be in atmosphere. If it is given in millimeter, then you convert it into atmosphere. 1 atmosphere is 760 mm of Hg. So let us take one numerical so that it will be more clear. So one example we have taken. So let us solve this. So procedure which we have just now studied, that we will apply. Okay. In Dumas method, okay, for estimation of nitrogen, 0.3 gram of an organic compound. So mass of the organic compound is given, so that will be used at last. 50 ml of nitrogen collected at 300 Kelvin temperature and 715 mm pressure. Calculate the percentage composition of nitrogen in the compound. So same question, let us try. So what we will apply? First we will apply PV equal to nRT. Then we will write PV is equal to N. N means given mass of dinitrogen by molecular mass of dinitrogen RT, and from here we will find given mass of N2. So given mass of N2 will be PV into molecular mass of N2 by RT. So this into this divide. Now, once we find given mass of N2 divided by total mass into 100, that will give us the percentage composition of nitrogen. Now first find P. So first pressure should be of dry gas. So how we will find pressure? The pressure of dry gas is equal to pressure of moist gas, pressure of moist gas minus aqueous tension, minus aqueous tension. Just now we have written the formula for finding pressure. What is the pressure of the moist gas given? 715 mmHg. 715 mm. What is the aqueous tension? 15 mm. Now what will be this? 700 mm. So this is the millimeter, but the pressure what we use, that is in atmosphere. So convert this millimeter into atmosphere. Now we know 760 mm is 1 atmosphere. 760 mm is 1 atmosphere. So 1 mm will be how much? 1 by 760. So 700 mm will be how much? So 700 mm will be 700 by 760 atmosphere. So 700 mm will be 700 by 760 atmospheric pressure. Okay. So first term we got pressure. Pressure of the dry gas, that is pressure of the moist gas minus aqueous tension. Moist gas pressure 715 is given, aqueous tension 15 is given, mm. We know that 760 mm is 1 atmosphere, so 700 mm will be this. Why we are converting in atmosphere? Because in R the value of R is 0.0821. 0.0821 liter atmosphere per Kelvin per mole. So in unit of R it is pressure, unit is atmosphere, so we are converting. Next, volume. What is the volume given? Volume is 50 ml. So volume is equal to 50 ml. Convert it into liter. So 50 ml will be how much liter? If you want to convert into liter, divided by 1000. Divided by 1000. So it will be liter. Okay. Now next term. Molecular mass of N2 is how much? 28. we know that molecular mass of N2 is 28. 14 nitrogen, 2 time is there, 28. 28 gram per mole. What is left? R we know T. Temperature should be in Kelvin. What is the temperature given? Temperature is 300 Kelvin. So this is 300 Kelvin. Put the all values. So this will be pressure. Pressure is 700 by 760. Pressure is 700 by 760 into volume. What is the volume? 50 by 1000. Molecular mass of N2 is 28 divided by R 0.0821 T 300. Now simplify it. After simplification, we will get the given mass of N2. Okay. So this will be. So this implies given mass of N2 will be how much? So 7. This 0 0 cancel, 0 0 cancel, and this 1 more 0, this 0 will cancel, and 5 6 jar 30. So this will be 7, okay, into this one 28 divided by 760 into 100 into 0.0821 into 6. Now simplifying this, after simplification we will get 0.0524 gram. So we get the given mass of N2. Now problem is solved. We have to find percentage composition. Therefore percentage composition of N2 by formula given mass of N2 by mass of organic compound into 100. So this was the formula for finding mass percentage, given mass by total mass into 100. What is the given mass? 0.0524. What is the given mass of organic compound? It was 0.3 gram. You can see in the question. Just back the video and you can see into 100. Now simplify this. After simplification you will get the result is how much? So just simplify and it will be 17.46. 17.46%. So this is our final answer. Percentage of N2 in the given compound is 17.46%. So in this way we will find the percentage composition of dinitrogen with the help of Dumas method.